Hello everyone, in this video you will learn how to solve simultaneous equations using Cramer's rule. Let us consider a system of equations where we have to solve for x and y. Let's write that as a1x plus b1y equals c1 and a2x plus b2y equals c2. Next, let us define a matrix called matrix A, where we write down these coefficients in this exact pattern. Therefore, matrix A is going to be equal to A1, B1, A2, and B2. Next, we simply consider the determinant of matrix A, and therefore, that A, this is called determinant of A, is equal, as we know, A1 B1 minus A2 B2. Next, let us define another matrix. Matrix is called AX. And now this matrix is going to be the same as A with just this particular first column, which we are going to call the X coefficient column, replaced by these constants C1 and C2. So instead of A1 and A2, we are going to have C1 and C2. Therefore, that is going to be equal to C1 instead of A1, and then B1 that remains unchanged, and instead of A2, we have C2 and B2 which remains unchanged. And then we consider the determinant of that too. And therefore, that is going to be equal to that AX equals C1 B1 minus C2 B2. Similarly, again we are going to define another matrix AY, and as you may have already guessed, it's the same thing that we did before, except we replace this column with C1 and C2. So this is the Y coefficient column, and instead of replacing A1 and A2, we replace B1 and B2 with C1 and C2. So therefore we get A1 here, C1 instead of B1, and A2 that remains, and C2 instead of B2. And we get the determinant of that too. Determinant of AY, which is going to be equal to A1 C2 minus A2 C1. Now these determinants, I'm going to call it the first one delta, the second one delta X, and the third one over here delta Y. And using this, we can very clearly say we can get this extremely simple solution that X is going to be equal to delta X divided by delta, and Y is going to be equal to delta Y divided by delta once again. So for any system of equation, this solution holds true, and therefore this is a very powerful concept because Cramer's rule can be used to solve even larger systems of equations. Now let us get into an example to thoroughly understand this technique. Now let us consider this example. Like we did previous, we write down that matrix A, which is going to be equal to 2, 3, 1 and minus 1. So that's simply writing down the coefficients of n, x and y in this exact same pattern. And then we know that delta, being the determinant of A, is going to be equal to 2 into minus 1 minus 3 into 1. So that's going to be equal to minus 2 minus 3, which is equal to minus 5. Then we write down AX which is going to be equal, we just replace 2 and 1 with 13 and 1. So we have 13, 3, and instead of 1, we are going to have, since it's 1 again over here, the constant is also 1, it's going to be the same 1, and then minus 1. So then we find the determinant of that also, which we are going to denote as delta x, which is equal to 13 into minus 1, minus 3 into 1, which is equal to minus 13 minus 3, which is minus 16. Next, we write down A, Y. So this matrix is just A with the Y coefficient column, 3 and minus 1 replaced by the constants 13 and 1. So we have 2, that's unchanged. And instead of 3, we are going to have 13 and 1, that's unchanged. And instead of minus 1, we are going to have the constant over here, which is equal to 1. So that is AY, and we get the determinant of that 2, which is denoted as delta Y, which is equal to 2 into 1 minus 13 into 1. That's going to be equal to 2 minus 30 equals minus 11. Now it's simply a matter of using that equation. We know that x is equal to delta x over delta, which is minus 16 divided by minus 5, which is 16 over 5. Then y we know is equal to delta y divided by delta. And we know delta y is equal to minus 11. Delta is minus 5. So y is equal to 11 by 5. As you can see, this is a very simple technique, and understanding would be very easy for you if you just go through the problems and practice this a bit more. If you have any questions, please feel free to ask all of your doubts in the comment section. It is important that you understand this technique because, like I said before, this can be used to solve even larger systems of equations that can come through to you in other engineering applications and so on. With that, I'd like to end this video and thank you for your attention.